So we're going to be taking a look at unlocking predictive reliability, continuous waveform capture, and electrical signature analysis. For those of us who are electrical engineers, we know what that is, because we all know what CWC is and also the ESA for uptime. So Dennis, I've got to say, let's get started right away to you. Bit of an introduction of yourself, because I actually think this is the perfect conversation. And I'm also going to thank so many of you because you actually provided us with questions to ask Dennis. So brilliant. So Dennis, go ahead. Let's get started here.
So a little background on myself. I do have an electrical engineering degree in undergrad for power systems and a master's in power electronics. I worked in the semiconductor industry for a couple of years, and then I went back and did a PhD in CAD tools for VLSI. So very broad background in electrical engineering. This is Volta Insite is actually a project that we started about 2 years ago officially as a company that we've started deploying and commercializing our product. But it's been a project that we've been working on in the background for the last 7 or 8 years. So that's the quick summary.
Perfect. Let's get started to learn about Volta Insite because the insight is absolutely critical here.
So I'll give a more background understanding on what the product is, and then I'll get into why we built it. Fundamentally, we have a cloud-based monitoring solution for critical electrical assets, right? What that means is we've built a full stack IoT platform from the hardware all the way into the cloud, and the analysis that is happening in the cloud is all our proprietary development. So that has enabled us to effectively be able to understand what is happening from a utility standpoint in very high resolution. So we have like 20 kilohertz of sampling. And then we also are able to create specific thresholds and event captures for our system. So there are two things that enable us to run this continuous capture. One is the hardware that we've built and the algorithms associated with compressing some of that data and maintaining it in the back end so that we don't blow up with too much data. And the other piece is the fact that we are running this continuous waveform capture. Now that gives us flexibility into electrical signature analysis. So this is an example of some utility transients that we've captured out there in the field. And because we do that continuous waveform capture consistently, so the first graph you'll notice is 1 to 10 second capture. It's actually very compressed. It's all the waveforms that are being shown on the second graph on the bottom. And you can zoom in and you can check your power quality event, which is only lasting for a few cycles. Now, how does that translate to anything within a data center? Well, that voltage variation may actually set off a rack or have servers being reset, for example, or even affecting your cooling system, like a motor kicks out because you're overloading and so forth. So because of our continuous monitoring and the event captures that we have, we're able to capture all of this and analyze it and give some type of intelligence on the back end as to how potentially this can be addressed. So that's utility transient. Now, on power quality, it's important to understand that what is always good within a facility is to have this continuous waveform being delivered to all your assets, whether it's a rack or whether it's an actual pump for water or your air handling unit. And again, because now we are always capturing these waveforms, we can see slight anomalies that your typical DCIM is never going to capture. And what that means is if we have these anomalies captured, we can go back and say, well, this is potentially a bad breaker or a bad contactor that's starting to fail. And this is a good example of a contactor that's actually failing within 1 day. So early in the morning, you'll notice the voltage variations very slightly happening. That's at 6 a.m. And then towards the end of the day at 4 p.m., you'll notice that contactor is losing one phase, and now you're single phasing your motor, which if it's on a long enough cycle, you're gonna destroy that piece of equipment. So that's the beauty of being able to capture these waveforms on a continuous time. And there's always these other things of ghost electrical problems within any facility, whether it's a data center or a manufacturing facility. And again, that leads to different pieces of equipment coming online potentially or malfunctioning. So again, if we're running this continuous waveform capture, the beauty is we can see everything. This is a piece of equipment that was malfunctioning in the field, and you'll notice a massive current spike with a lot of voltage variation being created on your power source. So being able to track all these events throughout time gives you very good understanding and potential diagnostics on the back end to be able to fix problems very quickly. So that's continuous waveform capture. Now, if we're always doing continuous waveform capture, we can go one step further into what's called electrical signature analysis. And the basic premise of electrical signature analysis is that anything to do with voltage, so you're measuring voltage and current at one particular point, anything in the voltage will be happening because of your power source. And anything that you see on the current side will be a consequence mostly of the combination of voltage and your load. So if your voltage is stable and you see something happening in your current, you know the issue is on the load side. That's the basic premise of electrical signature analysis. Now, what that gives us is the ability to go and look at electromechanical equipment. This is more for the infrastructure and operation side and the generation side, in that if you're doing this continuous waveform capture, now you can take the current, if you want to look at your specific load and you want to look at any type of electromechanical degradation, and you can map that into the harmonic spectrum. So you take your long, let's say 40-second current waveform capture, and you turn that into the harmonic spectrum, so you get a high resolution harmonic spectrum. And as you do that over and over and over again, you can go and trend specific harmonics over time to see the degradation of that mechanical assembly. In this particular case, we're showing an example of a fan belt getting looser over time, so the amplitude of that harmonic is trending upwards. And how do you come up with that harmonic? It's a basic geometric calculation to map back to the operating synchronous speed of the motor, for example. So this is a great example of ESA and being able to capture those harmonics over time on a continuous time frame and then map them back to see how the trend is occurring. So that's the quick summary of Volta Insite.
Absolutely perfect. So, Dennis, what we did was, as you know, we reached out to a whole lot of people in the industry, co-location, hyperscalers, enterprises, every manner of form, and a lot of different players. One of the biggest questions that came up, and we've talked about this, Dennis, I can't make head or tails from this data. I've got all the data coming in, but I still can't make head or tails. Why is data capture critical? More importantly, am I getting the right or wrong data? I love that wrong data.
Right.
What does that even mean?
So,
I mean, head or tails?
This is, that's an interesting statement, because one of the reasons when we began the project was effectively, everyone had an opinion within a facility, right? One of the exact examples was there was a VFD and motor and it was constantly blowing up. I got called in to do my analysis. This is pre-Volta Insite. And I showed up with oscilloscopes and different power meters, and I started capturing data to try to understand what is happening. So we were there for a good 8-9 hours just taking measurements. And then we had to go back and figure out, okay, what do all these measurements mean? So this is kind of the birth of how Volta Insight was. What if we could create a platform that was intelligent enough to give you all that data, crunch the data, and actually give you a prescription, an intelligent prescription as to exactly what is happening.
So kind of explain predictive analysis, predictive understanding, doing things before you're in trouble.
Right.
Because one of the other comments that came up from here was, data provide real value, but I don't think I'm getting value.
Right.
What's that?
Right. So there's a lot of that. Unfortunately, a lot of monitoring companies will sell you equipment, and good luck. It's up to you to figure out what is happening. The way we do it at Volta Insight, we actually sell you the equipment. We monitor the equipment for you in parallel sort of working step with our customers. And we create alerts as necessary, right? That's one piece. The other piece is that a lot of the monitoring equipment doesn't have the level of intelligence. We have a back-end library that we actually access now, and we've developed over the last few years to give you a specific prescription as to what is happening, right? Now, on the trending side, you all heard about Heathrow. It went down for 18 hours, right? A substation caught fire. In my opinion, there's no such thing as an immediate catastrophic failure. It's something that has been accumulating over time, and eventually it gets to the point where it does catastrophically fail. So I don't know what the latest information is and how it caught fire, but whether it was overloading over time or there was insulation breakdown, a lot of that could have been captured with enough high resolution data, and obviously the people who are able to interpret that data, or a software intelligence tool that is able to interpret that.
Perfect example for all the people who are angry at Heathrow Airport.
Right.
So the next big question actually came up from a huge co-location provider, monstrous all around the planet, Dennis. They said, why buy another system? I've already got EPMS. Right. No, listen to this list. He's already purchased EPMS, EMTS, BMS, and he's got a DCIM, and he goes, why is this happening to me, and why should I buy another system?
That's a great question. You would think that the system that you buy is able to provide all the value that you need, right?
Exactly.
Unfortunately, there's a lot of segregation in all these different systems. I'm very familiar with DCIM, or somewhat familiar. I'm not an expert, but from a power standpoint, what you're going to get in a DCIM system is RMS values of voltage and current. You can do some power calculations. You can track how much power your rack is using, for example. What you're not going to see in a DCIM is when you have that NVIDIA 600 kilowatt rack and you flip the switch, what's the inrush current into that effectively capacitive load? And is that going to affect a voltage drop on the rest of your system? And, how do you avoid some of that? So the Volta Insight 20 kilohertz high sampling rate, and we can even go higher, gives you correlated data of all the assets and how they behave and how all that interbehavior between the systems works, right? So that you can have a great picture as to what is happening.
So you can actually work with inside other DCIMs, EPMSs. You actually work with them. You've got that capability. Perfect. Yeah. All right. From a very large bank, financial institution, how agile is Volta Insight? Because we're already into looking at generative AI. So do you have the capability, and do you have any partnerships?
Yes.
Because we're looking at this rapidly, and we need to elevate what's happening and how we're dealing with these problems. So can you talk about, big question, how agile is Volta Insight, and what type of partnerships do you have driving towards this?
So we're very agile. Like I said, we're 2 years young. And we are a small team of very highly capable engineers, 23 people in total. We work with a lot of industrial customers at the moment, and we've actually integrated very specific solutions, cloud to cloud, if necessary. So we can actually work really quickly to integrate with anything that our partners may desire.
And I thought this was interesting. The note on the side was you've partnered with Apollo.
And we have partnered with Apollo on the generative AI, for those of you that are not aware. So we are looking at our fault library and trying to take that into the AI level such that the prescriptions are accurate based on all the history of information that we've accumulated for all the equipment that we've been learning on effectively.
Got it. So another one that came up from a specific operator out of Somerset, New Jersey, large player, was one of, I have spent a tremendous amount of money on all my critical components. How do you assist in the health and the longevity? Because the comment was, I'm advancing the concept of moving out the lifespan of my equipment.
Right.
So can you support that lifespan, but also the health of the critical components too? I feel like you're helping people who've already got high blood pressure. Get rid of it.
So yeah, I mean that's a great question. And on terms of longevity and how to prolong equipment life,
right,
you want to ensure that you get anything that you can address early with low maintenance. So this is the difference. I think the contactor example that I showed previously, if you can get those small voltage variations and know that your contactor is starting to fail, you can go change a $200-$300 contactor before that contactor fails to the point of single phasing your motor, and now you're also changing out your motor at $20,000 or $30,000, and there's downtime associated with those changes. So a contactor may take you 15 minutes to change out, but a motor, when that fails, that may take you out for an entire day. So, being able to capture those will definitely extend life of the equipment.
Fantastic. And you can actually plan for it then. I love this. Are you watching 24/7? Are you watching?
Yeah, we're watching 24/7. Our algorithms are watching 24/7, and whenever we're at work, we're watching too. So
okay. So during that period of time, and watching 24/7, you are also building a database of their life cycle management, their issues, their problems for their infrastructure.
Yes. We work closely with the facilities in a typical customer operating agreement, let's call it. We will sit down once a month. We'll go over the equipment list. We'll see what we observed. Critical alerts like single phasing, obviously that gets sent out immediately. But if we see small harmonic trends on something like a belt loosening on a fan for cooling or a chiller system, that gets alerted over time. That will be on the monthly call that we set up. And there's a discussion. So we're constantly learning about the equipment within the facility ourselves so that we can do a better job for our customers.
Okay, the last question that came up from quite a few people was, since you're so young, can you provide me of a couple of examples? Talk about hard to reach places.
Right.
Places I like that one. That one does me in. I like it. Yeah, it's called the raised floor. Never send me there again. Broken gearboxes, or whether my equipment's on and off, because I love this expression, I'm lied to all the time.
Right.
What? So can you really talk about some of the examples where you've helped with overloading, you've helped with poor data, poor diagnostics, hard to reach places? People are asking, you're 2 years young, help me understand more about how much you've helped.
Yeah, so fortunately, we have a monstrous customer in the manufacturing space that gave us a head start. So we've been learning with them. One example, the beauty of electrical signature analysis, first and foremost, you don't actually have to be on the equipment to monitor it, right? You can be in a clean electrical room measuring voltage and current at the disconnect or the motor controller. That's awesome because now if you can monitor a piece of equipment that's, in a tower somewhere, not easily accessible, you can understand how that equipment's behaving. And once you see an anomaly, you can actually send somebody to take a look, right? So that becomes extremely valuable. Some other examples on electrical signature analysis, we've had gearboxes that we've been able to identify. One gearbox in particular that we said, okay, there's an increasing harmonic, this gear needs to be changed. Maintenance went ahead, changed the part out within the gearbox, the actual gear. We saw the harmonic drop for a little bit and then start to increase very rapidly. We alerted them again. They went back, they looked at the part, and it turns out the part was the wrong part. It was not a hardened gear that they should have used. It was a softer material gear. So we're able to capture some examples like that. And then, we've had other like life critical examples where a contactor has actually welded shut, for example, on a motor. The motor is supposed to be turned off, right? All the control systems are saying that motor is turned off. The motor is still spinning with very low load. No one knows that it's actually happening. And we alert the facility and say, we're seeing single phasing on this motor with very low current. Obviously, it's not a catastrophic event because you're not putting the motor under load. But if you start putting this system under load, you will fail. Turns out the contactor had welded shut and it was not opening and we were running under single phasing. So if there was an event at some point where there was an overload or an inrush current on that particular motor, you would have had significant catastrophic failure. So we're able to identify a lot.
Perfect. Another big question that came up around, have you ever dealt with let me read this again. How AI-driven electrical monitoring can future-proof compute infrastructure? And I think the issue here is everything's going AI. I mean, even my bloody toothbrush is AI now. It's driving me crazy. So my question here is, how is the AI-driven electrical monitoring future-proofing? Because really, we've got to future-proof these issues.
So there's a lot of different equipment out there today.
That's the point.
Either on the generation side or on the consumption side. There's very few technicians today that know everything about everything within a facility. Unfortunately, a lot of the older guys that were around that knew everything, they're retiring. So now we're moving into a new sort of paradox where you have all brand new equipment, a whole bunch of different equipment, and the new generation of technicians are, they don't have the experience, quite honestly, right? Another problem that I've heard recently is a lot of these data centers now are being placed in very remote locations where talent is hard to find. So the more you can actually do from a software monitoring standpoint, the better. I don't know if I answered your question on that one.
No, you did. Actually, I have to say, it was actually from a very large car company that has edge everywhere. And they were saying, I don't have people who show up for months. So you just answered that one. Genius. Okay, we're right at the end of time, but what I wanted to get to was a final comment that came from a very large hyperscaler. So I'm good at getting past the best guess, but how can I use my best guess better? I don't understand that. Getting past the best guess.
Yeah.
Are you trying to tell me people have just been sticking their fingers up in the air?
More or less, yeah, I think so. So back to like DCIM, voltage RMS and current RMS, it gives you some level of understanding as to what is happening in your equipment. But if you have 20 kilohertz of sampling, you can see all the transients. You can understand exactly what is happening, even for small amounts of milliseconds that may be kicking equipment out that, these are the ghost electrical problems. So if you have data, you can figure it out. And the story I like to tell around that is I was actually years ago in a pumping facility where a 300 horsepower motor was running fine. the facility decided to put that motor under VFD. So they deployed a $100,000 VFD to run that motor. Great. With utility power, that motor and VFD combo was running just fine. As soon as they tried to kick up the backup generator and run it under the backup, it would start up, it would spin up for a while, and then it would kick out. No one understood why it was happening. The electrical contractor, an engineering company came in. They did a couple of measurements, right? Low level of granularity. The solution that was proposed by both of them was a $200,000 power filter. And that may solve your problem, no guarantees. And when I showed up, I heard this, and I'm like, well, what? Show me the data. Like, what's going on? So we actually went with our oscilloscopes back then, before the solution existed, and we captured all the data. We analyzed them. We said, okay, this is the problem. On the backup generator, there's some harmonics being produced. The backup generator, the voltage regulator on the backup generator is actually, fluctuating and creating some noise, and it's creating an oscillation on your voltage. So just put a filter right here and it'll solve your problem. And it was a $200 solution instead of a $200,000 solution. So that's the quick answer.
Well, I've got to say we're out of time. I want to give everyone the opportunity to at least meet with Denis. I've got Howie in the back too. Fantastic, available to talk with you guys. So with that, Denis, thank you so much. Really appreciate your time.
Appreciate it,
folks.
It's been great.